Hey everybody, welcome to another video in the Master Data Management in SQL series. My name is Elric. So far, we have created databases and files, and even created a table structure to help generate our tables. We learned about one shape, the class family type base shape, and created several subjects in that shape. So, in this episode, before we get to the other shapes, we are actually going to fill some of these tables with data, and that's going to help us progress in the development of this system. So I'm going to go ahead and get started and just talk as I code. You're welcome to follow along, or you can just watch, either or. We're going to have some fun. So the first thing I want to do is, because we don't have a relationship table or definitions defined, we're going to have to manually do a few things. And I'm going to add a new column to my database table called sysref system ID, and it's going to be a foreign key, non-nullable, with a null default. And I'm also going to create a relationship to the system table for this specific ID. Close it and save it. And I'm going to do the same thing. Actually, before I do it for the data set to database and data point to data set, I want to bring up a point that someone was talking to me about, where we have the ownership columns at the beginning of the table. And I have chosen to use the tenant before the dataset number. Now, when I was talking to this individual, there's really two mindsets for this ordering, because this is going to be a part of our clustered index, the physical ordering of the table. And we had a nice long discussion on whether we should group data by the tenant, which would be a client or a template or just an abstract container, or if we should order it by the table. And what that means is that on the physical drive, you're either going to have all of the tenants data grouped together, because the tenant ID would be first in the B tree structure, or the physical file would look like all the tables are together. And I just wanted to bring that up because I don't think there is a right or wrong to that. I think that really depends on your use. If you're not really utilizing the tenant, then maybe you want to then maybe you want to have the specific dataset number first, so you can keep all your tables together on the physical model. So I just thought that was an interesting point, and I wanted to bring that up as we added another item to that physical model, because the clustered index would essentially contain these four keys: the tenant, the dataset number, a parent key if applicable, and the type ID, which will always be there, or the taxonomy ID, I should say. And without the taxonomy ID, it would be the cluster group. So I thought that was a good point, or a good thing to talk about. And that's really what these videos are about, is to get people thinking and talking about this this way of managing data. Excuse me. So, back on track, I'm going to go ahead and go to the dataset table design it, and do the same thing. I'm gonna insert a column for the database ID. Get a foreign key, no nulls, with a null default, and a relationship. To the database table. And we're going to save it. And one more time for the data point. Sysref data set ID, UDT foreign key with a null binding and a relationship. And then we'll save it. So now's the fun part. I'm actually going to start coding. That's what I enjoy to do, or that's what I like to do. So I'm actually going to manually create a record. Oh, wrong table. In the system class, because we don't have anything yet. A class of systems, like what type of systems do we manage? And I'm going to actually have one for owner. This system is the operator. Actually, yeah. Key name of owner. It's ID 1. And I'm going to add 2 more, just so the system class kind of makes a little bit more sense. Internal, and we'll do external. And now I'm going to add a family for both the owner and an external. So I'm going to edit rows. We don't have these in place yet. For the owner, and for external, which was system class 3, I'm going to add Microsoft. This is very important for future projects, and I just want to kind of, this being the introduction to the system, just want to kind of give hints and plant seeds for idea trees. So now type system type family main. This is going to be just to give it another main. Because that's what it is. I mean, I'm only going to have one tenant that essentially operates itself, and one system that rules them all. But for the external family, the external class and the Microsoft family, I'm going to add two more types. One for AdventureWorks, which we will be splitting up a while from now, and I'll fix that spelling error. I think it's Wide World Importers. The system is a version of Wide World Importers. So this is all essentially when we restore an AdventureWorks and Wide World Importer database, we will link it to that. We will link this type, give it a version and system. So a database requires a system, and we'll be able to say, hey, this is my database. These DB core, DB input are my databases. And this AdventureWorks 2012 DW or whatever it is, when we download it, will belong to the external class and the Microsoft family and the AdventureWorks type and whatever the database's name for the system, because their system is contained in one database. We do the same thing if we were to take in multiple databases. We want to type it like this. But for now, I'm just going to create my system. This is type 1, I believe. Yep. I'm just call it version 1. And that's good. Now we have our first system. So I want to kind of repeat the same thing for databases. So that's the first table that we are going to fill. Database class of SQL, because we can actually store folders and such as a class of databases. So these databases are SQL databases. The family is going to be local. And the database type we've already used the database type before. One of them being main. One of them being history. One of them being archive. and the last one being snapshot. Awesome. So now we're going to go ahead and fill our databases, or our database table. And this is how we're going to do that. First, we're going to from master.sys databases. We're going to filter this down to a list of databases that only fit our system. And I'm going to give a two-part where clause. I'm gonna get this formatted. Where the name is not in the required databases, so we don't really care about those. And the name starts with our prefix. So that should give us a list of our databases. And this code is going to be our cursor. So declare database cursor for our databases. So that means I'm going to need database name variable. I'm going to go ahead and close this window. Just continue to code. Open. Fetch next from database name. And fetch. And there we go. Awesome. So this is going to loop through our databases. And now I'm going to show you another way to use the class family type table structure. Because this code is going to be stored in interface and we don't have synonyms created yet, but we are on the way to do so, we're going to have to hard code the database name. We also never want to call the table directly. We want to use views, but we cannot create those yet, so we are going to have to query the tables directly. going to copy this. Just going to copy this whole thing. Should get a auto formatter, but it's okay. Yep, and then we'll paste that in there. Family to class, and remove it. So, since we are working with local databases, essentially we are going to look for the database type name that closely matches our database name as it's coming through. So I want to create, see, I already got used to doing this here. We should no longer be using data types. We should actually be using, SQL native data types. We should be using our own user-defined types. I'm going to declare a database type ID and a database key name. Ooh. And we're going to add a where clause. We're going to take the right side of the string and compare it to the length of the key name. Or we're going to take the right side of the database name of that string. We're going to try to see if we can find a match for our system. It's as simple as that, really. So what I'm going to do is just run this to see if that worked. Let's see the database type ID too, or also. And you can see it's working, or from what I understand, it is working, it is changing. Oh. So now we can give it a type. We have the variables. I'm just going to get rid of the key name because we don't need it anymore. And I'm going to get rid of the print because we have verified that it worked. But I'll still need the type ID because the database table requires the type ID. Actually, I take that back. So we are going to do this anyways. Might as well do it now. I'm going to use that key name for a specific purpose. So now we loop through and we know that we're getting the correct database type ID. I'm going to get the database ID. From the database table. Oh, copy the wrong thing. Ugh. There we go. Where I'm going to match it on the name and the type ID. And that is because we can actually have the same database in there multiple times under different classifications. They may essentially be the same thing, but because they have different purposes, they may be handled in a different way. And that is why that is one of the weird things that we can do in this system. So we can have the same database in our database table multiple times and still kind of relate it for the specific purpose that it needs to be related to. So right before I select my database name, I want to make sure that it's null, because this is used inside of the cursor. The database ID is used inside of the cursor. It can carry a value, so we want to make sure to null it out. So now if the database ID doesn't come back, we know it's not in our system. To make sure to get this. And then we're going to add it to our system. Now we're just going to go ahead and format it. Because I want to make sure that we have everything in here. And add our values. What I like to do, can't insert that. What I like to do is just copy this, paste it here, and just replace them. Oh, we need a system ID. I forgot about that. And to get the system ID, we can do something neat where, because all these patterns exist, can essentially do this. So I have a owner. I forgot what I named this already. Main. Run it again. I believe I did main again. Yep. And then we're just going to copy this. Replace type with nothing. Yep. And family with type. So now, let me go ahead and minimize this and run it. Excellent. So this means we can have several systems in our system table named version 1, but it's really the classification that breaks it apart and allows us for some really unique data patterns. And I'm going to leave this on the outside of the cursor because we only need to grab it once. And like I said, the key names are there because we do not want to say 1. You know, we have to do 0 now because we can't do anything else. And now I'm just going to fill these in. Database was found by the system object database finder tool. There's no abbreviation, no header, and the key name, I'm actually going to replace the database name. Replace database with nothing, and replace the database type key name with nothing. And all of our key names have to be upper. And what that will do is that will make all of our interface databases their key name interface. But when we grab the database and the database type together, we will see interface main, interface history, interface archive, and interface snapshot. I'm just going to give them null. And these are not going to be cleansable, things that I find in this system. You can always update them later. That is it. So this is our first finder. Let me just go ahead and test it on one record so we don't have a lot to clean up. And that record's going to be interface main. And it said it worked. Let's run it again. And nothing happened. It's looking pretty good. So the next step is to remove the top. And I'm gonna copy this code. We're gonna run it on interface main. Database finder. Finds databases in the system and adds them to the database table. And it doesn't need any parameters. So before we save this, let's go ahead and comment it. Nope. Sometimes it's difficult to think backwards. And we're doing this again because I'm going to rip the comments out and make Wiki like a self-documenting database. Easy enough when you figure out the patterns. Just for good measure, we'll do that. And end database loop. Create. Execute. And let's give it a go. Now let's see if it worked. Beautiful. So now we have all of our 64 databases properly typed. And since we have a code base, I'm going to end this video here, and then the next video we will just find and replace our code we just created, the procedure, the database finder, for the data set and data point pieces. So that'll be really cool. Well, that's about it for today. We did is we manually created some parent-child relationships, or some parent foreign keys, because our definition table structure isn't functioning yet. But that allowed us to start getting data into the system. So we're going to continue to get data into the system before we can create these definitions. And yeah, learned a little bit about the class family type structure, and there is a lot more to learn. So thank you very much for watching. I hope you enjoyed, and I will catch you next time.